The topic for today's webinar is Oracle Database Security Vulnerabilities Explained. And so we're going to kind of take a step back and talk about what an Oracle security vulnerability is, and then I'm actually going to go into great detail and actually show you in code what the vulnerability is, how Oracle fixed it, and actually how it can be exploited. So what we're trying to do here today is give you a little bit of background, give you an understanding about when you're applying those CPU patches, exactly what's getting patched, why they're there, and everything else. So let's get started. Again, my name is Steve Coase. I'm the Chief Technology Officer for Integrity. And so we'll start off with a little background about the CPUs. And the motivation here is to talk about things that you may not know about the critical patch updates. You're applying them each quarter. But hopefully give you a little bit more information about some of the aspects of the CPU, how they work, etc. And then we'll actually talk about vulnerabilities in general in the Oracle database, and then talk about the security bugs in detail. And again, I'm going to take a couple of security bugs and go through them and show you exactly why they occurred, how they're exploited, etc. And then finally, we're going to open up for some questions and answers at the end. So before I get started, I'm going to give you a little bit of background about Integrity. Integrity was founded in 2001, and we specialize in Oracle security. So we work both with the Oracle Business Suite and the Oracle database. And we do have some products. One is AppSentry, which does database security auditing. And then on the services side, we actually do security assessments for large Oracle customers who are running hundreds or thousands of Oracle databases, and we help them with their compliance needs, security needs, how do you do auditing, things like that. So that's just kind of a brief background about Integrity so you know a little bit about us. One of the questions we do get is why do you know so much about the CPUs? Well, we actually do a lot of research internally at Integrity, and we find a lot of the bugs that are fixed in the CPUs. We found over 72 security bugs going back all the way to 2003. So we're very active in researching, working with Oracle closely to actually get these bugs fixed and patched. So a lot of this information contained today is actually from our experience on actually finding security bugs, reporting them to Oracle, researching and analyzing the CPUs as they come out each quarter. So now let's delve into this critical patch updates a little bit. I'm going to try to give you some information here, not just general information, but hopefully information that you may not be aware of about the CPUs related to the Oracle database. First, kind of as a level set, when we talk about Oracle critical patch updates, we're talking about the quarterly releases by Oracle that are on a fixed schedule. So we know the next one's coming up July 17th, 2012. Oracle publishes the schedule out. And the reason they moved to a quarterly cycle was prior they were just releasing them ad hoc. So you had no idea when they'd come out. You couldn't fit the schedule into your patching cycle or anything like that. So they moved to, actually 6 years ago, a very fixed, rigid schedule about releasing CPUs. There's been 30 CPUs to date, starting with January 2005, fixing an astounding 1,300 security bugs. And there's 433 security bugs fixed in the Oracle database in those 30 different CPUs. And we're actually going to look at 3 of those in detail. But first I'll actually break down those 433 security bugs to give you a little bit more information about which types of bugs are fixed most often. So let's look at it by quarter. One of the questions we often get at Integrity is, well, obviously Oracle has to have fixed all the bugs by now. In our analysis and looking forward, that's really not the case. There's probably at least a couple hundred security bugs open with Oracle today, so the CPUs are going to continue. Yes, the number of bugs has decreased over time for the database, so the blue bars here show you the number of database bugs fixed per quarter. Well, the numbers are dropping slowly, but they really aren't going to zero. So we anticipate, at least for the next 12 months to 24 months, that there will be just a continuous stream of critical patch updates for the database. And also the severity of the database bugs have remained fairly consistent. Anything over 6.5 for the CVSS score is a fairly serious database bug, even though it's on a scale of 1 to 10. 6.5 still is very serious. And if you can see the blue line up there, that's really showing you that almost every quarter it's 7 or more for a serious database bug. So the CPUs still remain critical, and there'll still be a number of CPUs coming out over the next 2 years minimum, we think. So one of the things that people don't really understand about the security bug process at Oracle is how it works internally. Well, the obvious one is someone finds a security bug. It's either a customer or security researcher like Integrity, and it's reported to Oracle. Oracle researches a bug and develops a fix. One of the key points is when Oracle is actually developing the fix is they don't notify the person who found it of how they're fixing it or anything like that, and they don't actually allow that person to even test it. It's just all of a sudden a black hole. It gets reported to Oracle. Oracle says they're going to fix it. Then all of a sudden a fix pops out. That's caused a number of problems over time because Oracle fixes the bug the way they think it needs to be fixed, and they didn't think through the entire problem. So you do see cases where, and it's maybe 50 bugs over the 400 bugs, do get fixed over and over and over. So that's not an uncommon event, especially several years ago. Now Oracle's been doing a better job, but you'll see the same packages and things like that are fixed over and over and over because, well, they found the bug in one spot, they didn't look everywhere for it, they may have fixed it completely, things like that. Another aspect about the security patches that you may not know is security bug fixes are actually included in the main code line first and then backported to CPUs. So what happens is when 11.204 is being developed right now, all the security bug fixes are actually being incorporated into there. And then what they do is a lot of work that takes several months to actually take that bug fix and actually port it to 72 different database version and platform patches. So if you think about it, every version that's supported and every platform has to have a separate patch. And that has to be backported, it has to be regression tested, etc. So it does take them a while. So when you actually apply the latest database patch set, as an example, 11.203 came out recently. 11.203 didn't have any patches as part of the January 2012 CPU. And the reason for that was they had already incorporated all the security fixes into that release. So when you're actually installing some patch sets, you're actually getting hidden security fixes. Then another aspect of the CPU process is it may take Oracle 3 months to 3 years to fix a problem. One of the recent bugs that was actually discovered has actually been in Oracle since 8i and was reported to Oracle in 2008, and eventually Oracle's released a workaround in 2012. So that was 4 years for a single bug to be fixed. And so it's not uncommon for bugs to sit around for a long time at Oracle based on priorities and things like that. So as we look through the security bug process kind of in different ways, if we look at scenario A, this is the way most people think it works as well. Oracle gets notified, they fix in the main code line, they release the CPU patches, and then maybe a new version is released in the future. Scenario B is much more likely because some of these bugs take years to fix. So what happens is Oracle's notified, they fix in the main code line, now a new version's released, and there's no notifications in that new version. So nothing in the release notes or anything else would tell you that there's any actually security fixes. And then it takes them a while to actually backport it to all the old versions and platforms, and maybe a few months later a CPU patch is released. So if you are installing the latest patch set version, you are getting hidden security fixes, which is a slight benefit. And I probably wouldn't be installing patch sets just for that, but it is good to know that those are receiving security fixes first. Another area that we see a lot of problems with is the critical patch updates baselines. So what happens is you do a database upgrade. So you may have upgraded from 11.202 to 11.203. Well, in that 11.203 patch set, the only thing included is the CPU that was available when that patch set was released. So when 11.203 was released in July 2011, it included the July 2011 CPU, nothing else. So if you actually have an 11.202 database, you apply all the recent CPU patches, and then you do an upgrade, your CPU baseline is actually reset because there is no internal version of code within the Oracle database. So the database package is updated for a new release. It's actually replaced. So when you went to 11.203, you actually reset your CPU level back to July 2011. We catch a lot of people during our security assessments on this that the DBAs just don't understand the process. And we'll go through and say, no, you don't have the most recent CPUs applied. And they say, oh, yes, we do, yes, we do. Well, did you do a database upgrade recently? And say, yes, we did. And oh, by the way, you've moved backwards when you actually did your database upgrade. So the takeaway from here is that when you do database upgrades, you always need to be looking to apply the latest CPU patch. There are some minor caveats, just as you're applying the most recent one that was just released in the last month, may not be where you have to do it, but most people don't do that in a large environment. Very seldom can you apply the latest database patch set within a month or two of release. If you're at least 3 months away from release, you have to always apply the latest CPU. Another area that catches a lot of customers is that database CPU support is very rigid by Oracle. So Oracle is only supporting a database patch set level up to 18 months basically after release, unless it's a terminal version. So Oracle's got basically a stick here for everyone who needs to apply security patches. They're basically trying to prod along their customers to do database upgrades very quickly. So basically you're not going to be sitting around on versions for 2 or 3 years anymore if you have to apply CPU patches. So this is the chart. So a lot of databases are unable to apply CPUs because they're basically out of the CPU support. So a lot of people just move to 11.201. Well, by the way, now you have to be upgrading to 11.203 in order to get some CPU support. The 11.203 date here is estimated by Integrity. So Oracle is aggressively moving towards 11.204, and when they release that, the 11.203 date will actually be announced, and we anticipate that to be July 2014. So that's kind of a high level of the CPU. Just wanted to give you some information about things that you may not know about the CPU process. Now let's kind of delve into some of the vulnerabilities. And so what I'm going to talk about now is just the 433 security vulnerabilities in the Oracle database, and kind of give you some broad general breakdowns and give you some understanding what those vulnerabilities are. So if we add up the 433 vulnerabilities, and we went through this quickly, this is not very precise at all, but it kind of gives you a general feel of what types of security vulnerabilities are included in those 433. The biggest percentage is SQL injection. So SQL injection basically allows me to add SQL code to an existing SQL statement and have that code executed as a privileged user typically. Typically, SQL injection is thought of as a web application vulnerability, but for the Oracle database, this includes standard database packages. So, and I'll actually show you a prime example of this, that I can basically execute SQL code as the sys user and then actually have it call another function. Buffer overflows are a little bit more complex to exploit, but basically what happens with a buffer overflow is the Oracle developer didn't think about what should be passed in. So a database object name should be so many characters. Well, the developer at Oracle assumed it should be that many characters and didn't do any checking. Well, what could happen is I can pass in many, many more characters, add some assembly code to that, and then it will be actually executed at the operating system level as the Oracle user. And I'll show you where you can find some information on this. I actually won't show you an exploit, but these were basically very common back in 2005, 2006 timeframe. Not as common now. We see much more SQL injection. The third major area is privilege or permission issues, and I'll actually show you a very good example of this, where some developer at Oracle granted something to public that shouldn't be granted to public. Is the most common scenario for a privilege issue. And then all the other ones fall into different categories. So these may be denial of service attacks, those type of issues. There's lots of different things. Design issues would fall in other also. So now we kind of break down some more vulnerabilities. And so what I've done here is gone through and taken away a number of years, kind of the first years of the CPUs that were not as common now. So we went and took the data from January 2007 through January 2012. So now we're talking about 253 database bugs. One interesting aspect of the database security bugs is that most of them, in this case 80%, require authentication to the database. Only 19% over time have allowed you to exploit or attack the bug without database authentication. And the vast majority of these are denial of service attacks. And what a denial of service attack is typically in the Oracle database realm is that I can basically shut down the TNS listener and basically block access to the database. Very seldom can I actually bring down the entire database, but I can actually bring down the TNS listener. And that's the vast majority of this 19%. So the key here is it's typical to exploit a security bug in the Oracle database is you need a database session, which is very important. Well, when we talk about a database session, well, what privileges do I need? This is the true problem with Oracle security vulnerabilities. Is yes, 80% of the bugs require authentication, but of those bugs, 53% only need public permissions. So as long as I can have any sort of database connection, even if the person only has create session, they can exploit the bugs here. And I'll actually show you an example of one that's very easy to exploit. I can take over the Oracle user at the operating system level. So it's very powerful if you can have a database session and any sort of account. So this is the rationale why a lot of security experts on the Oracle database say don't allow people to connect directly to your database because they can take it over if I haven't applied the latest critical patch updates. And most often in any CPU, there's at least one bug that's publicly exploitable. So if we kind of take it to the next level, is saying, okay, of those exploitable bugs that I can exploit if I only have public permissions, what have published exploits? And what a published exploit is if I go out to Google, I can actually find information exactly how to do it. Well, most people say, well, these are really difficult to exploit and you have to think about it, you have to be an Oracle expert. Well, that's really not the case. So if I just jump out, we'll kind of make it full interactive now. So what I'm going to do now is kind of bring up a couple websites here. So this is exploit-db.com. And so there's actually websites out there that collect the information on how to exploit a security vulnerability. So what happens is Oracle releases the information, but they don't give you any details. And other people go through and say, okay, how do you do this? And they actually publish out very detailed code. So I'll just go in and search for Oracle here. And now I'll get pages and pages of different Oracle security vulnerabilities with detailed information. So I'll just click on one here. And these are actually pretty well commented out and things like that. Probably a lot more comments than your developers would even put in. So they actually show you exactly how to exploit it. And here's the code here. It's well commented. And what this is basically is doing partially, I think they're trying to hide the data here in this example. But basically it's a standard vulnerability in an XDB package. So there's multiple websites out here. This isn't the only one. So this is how easy it is to actually figure out some of these security vulnerabilities. There's not information published for every single exploit, but there's enough that all you really need is one to be able to take over the sysuser of a database. So as long as I create session, I basically am a Google search away from finding some of the information to take over your database. Again, some of the similar information, and this is for all Oracle products if I search Oracle. But here's an Oracle 11 GR2 multiple remote privilege escalation vulnerabilities. So we'll actually show you this example here. And so all I did for the examples that I'm going to present you today is just do some Google searches, go to some of these databases and get the information on how to exploit them. So anyone who thinks, oh, these are too difficult, my standard developers couldn't do it, or somebody from AP couldn't do it. Well, if you have a database connection, you can log on to a database. It's fairly easy to do Google, find the information, and actually take over a database and try to steal data or do whatever you want to do. Let's just kind of give you an example of how easy it is to do some of these things. So the key is a lot of these vulnerabilities that have public permissions can have published exploit code. So it's actually fairly easy. So if you're not keeping up on your critical patch updates regularly and allowing ad hoc access to the database with lots of different individual database accounts, or providing a shared read-only account to a database, it's pretty easy to take over an entire database without a lot of difficulty. The fundamental problem is anybody with a public bug that has some exploit code can take over your database. For all those eBusiness Suite users on the call today, oh, by the way, the Oracle eBusiness Suite does have a user that's already defined in every single Oracle eBusiness Suite environment, and the default password's pub. So you have an account, Applesys pub, with the password pub that anyone can connect to if they can connect to the database and basically take over your database if you haven't applied the latest critical patch updates. So that's how powerful this is. So that's kind of the background, and I just wanted to go through and give you some information about the CPUs, some background about them, and talk about the vulnerabilities in whole. Now what we'll do is actually take a couple vulnerabilities and walk through them in detail. So what I did was I kind of took a smattering, and I wanted to make sure that I covered a couple different areas and that there was public exploit code available. That was kind of my two rationales about why I picked these bugs. I could have probably picked at least 2 or 3 dozen. We looked through and kind of said which ones would be kind of the best ones to show. And so what we'll do is walk through each of these and talk about them in detail. So the first one is the SQL injection bug. And so this one was actually fixed as part of the January 2009 CPU. And so as part, when we talk about a CPU, Oracle releases a number of pieces of information about the CPU. The first piece of information is it'll be a CVE code. The CVE code is actually a standard identifier that's used across all security vulnerabilities. So if you go to Google right now and type in this number, CVE 2008-3979, you'll actually go find a lot of references to it. So it's very easy to find information once you know what the CVE code is. Then Oracle gives you a number of pieces of information, what component it is. The component is often in a standardly installed component. Very seldom do we see a lot of bugs in pieces that aren't installed by default in most every database. We've only seen one CPU out of the last 30 that we actually went through and actually had to do the analysis to say, would somebody actually have all these security vulnerabilities installed? So 29 out of the last 30 CPUs, you had at least something that would always be installed. So component's meaningful to at least understand where it is. The biggest piece of information you need to look at is what packages and privileges are required. This vulnerability actually requires a few more privileges than the standard create session. In this case, drop table and create table. I picked this vulnerability. One of the reasons I did was because it was kind of a cool little trick that it uses to actually exploit the database. And then the other area is remotely exploitable without authentication. Again, this is the number. 80% of the security bugs related to Oracle require authentication, so I have to be able to sign into the database. CVSS score is basically a number of between 1 and 10. The problem with the Oracle database is almost always the CVSS score will be low. A 6.5 is really a very serious vulnerability in the Oracle world. Most security people say, well, it's not a 10, I don't really have to worry about it. Well, because I can take over the database, but I can't take over the root of the server, well, in CVSS land, it says you have to take over root of the server to be a 10. Otherwise, it's really not that serious. Well, in this case, I can take over the entire database, all your data, things like that. So it's really a problem with CVSS than anything else. And the way Oracle compensates for that is they actually give you a partial plus. So partial means I can take over something on the server, and Oracle kind of then adds partial plus and says, well, you can take over the entire database server. So it is a serious bug, but very seldom in an Oracle security bug can I take over the entire server. I can't. It's very, very difficult on Unix or Linux environment to get to root. I can take over the Oracle account very easily. I can take over the entire database, but I can't really get root. Well, do I really care if I own the entire database? And it has 3 categories: confidentiality, integrity, and availability. So confidentiality is basically read, integrity is write, and availability is it online. So what we'll do now is actually I'll show you this vulnerability in detail. So we'll kind of jump around here. So I apologize if I lose everything as I jump through multiple applications here. So what we'll first do is actually jump out to the code. So what I've done here is I've actually gone through and pulled up the source code for this package that we're going to actually be talking about. So this code here was basically first published in 2005, and was basically, this is all from the same database, so this is pre-patch and post-patch. So this code really wasn't touched for a long time. And we'll actually jump down, and this is a SQL injection vulnerability. And what a SQL injection vulnerability is the developer at Oracle basically, instead of using bind variables, concatenated the statement together. And this is a classic SQL injection. Your developers are probably doing this in their web applications today already, unless they're using bind variables and you have a pretty strict security standard and security reviews on code. But what can happen now is this code is actually executed as sys based on invoker and definer rights. And so what can happen is I can actually inject code into the SQL statement and have it execute. And that's pretty powerful. So I can now execute something as sys, because if I can add something to the SQL statement, because it's not a bind variable, it's just concatenated together, it will then be executed as sys, because that's the way this package works. So how did Oracle fix this? Well, for all SQL injection vulnerabilities, again, this was fixed in January 2009, so this code was last updated December 2008, as you can see here. And we'll go down to the exact same SQL statement. And classic fix for SQL injection is basically they added bind variables. So when you talk about testing a security vulnerability, this, if you look through, that's a lot of questions we get, is how do I test this? Well, it's really difficult, because this is basically just in a standard package that's in Oracle Spatial that I may not be using, but it's installed by default. In Oracle, all they did was change it from doing by concatenating a SQL statement to using bind variables. So then what we'll do here is now we'll kind of jump out to SQL Developer. And so now I've got a connection to a database, and I've got very low privileges here. And this bug actually requires a create procedure. And it's kind of a cool little bug, and that's why I fixed it. So now as this user, I do need create procedure in this case. But typically in a lot I don't. I just need create session. And so what I did was write a little procedure here, just called it A. The key is for the procedure to execute as current user. So when the standard Oracle database package gets called, it'll actually be executed as sys, which then calls my package as sys. Well, since it can be executed as sys, I can just basically grant DBA to my lowly privileged user here called integrity, and I'll grant DBA to integrity. So actually what happens is whenever you create or drop a table, it calls a trigger. The SQL injection bug is in the trigger, and basically it's just checking to see if it's an Oracle spatial table. If it's not, it kind of continues on, but the SQL injection is in that check to see if it's an Oracle spatial table. And so basically I'm creating the table, and this is kind of where it's cool. The name of the table is actually the SQL injection. So you can see it's a really bad looking name of the table, but basically what it's saying is I'm stopping the open quotes in the concatenated SQL. I'm adding in the call to my package, which then will execute and basically grant sys to integrity, or DBA to integrity. So what we'll do is basically create the table. And that's not where it actually gets executed. It gets executed when you're dropping it, because it wants to know if it's an Oracle spatial table, and if you drop an Oracle spatial table, Oracle spatial has to do something. So in the check of dropping the table, it'll actually now go through. I drop the table. We'll go out and check what privileges now integrity has, and now integrity has DBA privileges. That's how easy it is. So that's a classic SQL injection in the Oracle database. And all this code I pulled out was, I modified it slightly, but it was basically, you Google for this CVE code and you can actually find all this information. So that's the first vulnerability, and that's a classic SQL injection. So I'm just basically calling and I'm executing something as a sys user. Very, very powerful type of bug. So the next bug we'll talk about is basically a permission or privilege issue. A permission or privilege issue is basically where the Oracle developer just kind of screwed up and granted too much to basically a standard package. So again, it's pretty much the same information, CVE code and things like that. But here, create session is all I need. But again, I need a database connection. 80% of all the Oracle security vulnerabilities need a database session. But again, if I don't need any privileges, I just can connect to the database. The only thing this account can execute is when I do this will be public packages. Well, I can read or write to the entire Oracle database. And oh, by the way, the CVSS score is only 4.0 on a scale of 10, even though I can write any data or basically do anything I want. And this one will actually allow me to write any file as the Oracle user. So what we'll do is now kind of jump back out. We'll go back to let's go to the code first. And so what I've done here is just bring up this standard code. So the security vulnerability is actually in the DBMS JVM export permissions. So when you basically import and export a database, you have to import and export the Java permissions that are part of the Java virtual machine that's in the database. So when you export it, basically it takes the permissions and exports them out, and when you import the database, it basically has to re-import those Java permissions. So again, this code is from 2005, and so this code's been around for a while. And if we kind of go through the code, it's just basically standard Oracle creating a package, standard package that's part of sys. But by the way, for some unknown reason, the developer went through and granted it to public. This made it through every single Oracle code review, went on for a couple of years until someone actually said, oh, that's a pretty powerful package, that shouldn't be granted to public. And they opened the security vulnerability with Oracle. And so what did Oracle do? Well, basically in February 2010, just had to go through and change the package. And so instead of granting it to public, which it should not have been granted to, they are basically here granting it to the import and export database roles. So again, how do you test this? Well, really it's not anything that would change functionality unless you happen to be calling this as part of a program or something, which I don't know why you ever do that. But basically, you'd have to test import and export would probably be the worst thing you'd ever have to test, but a lot of other things wouldn't work if you don't have the setup right anyways. This one's actually interesting is on the fix as well. The fix was to change the permissions, but since the public might already be out there, because when you upgrade a database, that you don't change the permissions, you grant more, you don't ever take them away. So in this case, Oracle actually had to add a second line of code when they rebuild and do the upgrade to actually revoke the permission on public specifically. So that's kind of what Oracle had to change. And that's how this is a pretty much for most Oracle security vulnerabilities, this is the level of detail that's being changed to the extent. There's maybe a couple more lines of code, but probably at least 80 to 90% of all fixes are this level of detail. They just made some mistake and they actually have to go make some minor changes, validate input, put more, things like that. These changes are not thousands of lines of code. These are changes or a couple lines of code. Here it's 3 lines of code were changed and that was it. But that's very typical for most security vulnerability fixes in the Oracle world. Some require some more, and there's always that exception to the rule. So now what we'll do is actually go out to back to SQL Developer. I'm actually in another database now. And then we'll go through this user and basically check create session. We'll check if they have any roles. So the only system privilege this user has is basically create session. And so here's the exploit. The exploit is kind of interesting. So the privilege is basically to allow the person to call the export permissions and import permissions. And so basically as part of that package, it allows you to set Java permissions, which a normal user shouldn't do. So then if I call some Java code, I can actually then do anything with the Java permissions. And one example of a Java permission, this is basically a creativity type attack now. Now that you've got the capability, you have to think about what you want to do. So it does take a little bit of effort to figure out, ooh, now I've got great power, what should I do with that power? And in this case, what we're trying to do is just basically give us full I/O permission. So we're granting ourselves the Java I/O file permission, basically to all files. And so now we'll go execute it, and this takes a second to execute. And so now what I've done is gone through and granted myself full I/O permission. And this code I am using here was basically downloaded out of a blog post on Google. If you Google DBMS JVM export permissions, you'll see multiple examples of this exploit code. So I didn't make this up. I'm just copying this from Google directly, and that was one of the reasons I picked this exploit. And then actually now what we'll do is call the wrapper function, and this allows me to basically now execute commands at the operating system level. And as an example, I'll just touch and try to create a file here. Let's go first check that our file doesn't exist. So I'll go through onto that database server, and we'll kind of do a list. So there's just 3 files there, nothing called exploit. Jump back to SQL Developer, and now we'll kind of run this. Takes a second to run. Doesn't really do much there, but now if we go back to the operating system level, I basically now have created this file called exploit. Again, not much of a deal that I created a temporary file in the temp directory, but oh, I could create a new rhost file, I could overwrite database files, I can do just about anything I want here as the Oracle user. Again, it's executed only as the Oracle user. So again, an example of within Oracle security vulnerabilities on Linux and Unix, I can do a lot of things in the database, I can do a lot of things at the Oracle level. I have a very difficult time doing things as the root user. I can't take over the entire database server, but I can easily take over the entire database. So that's kind of a very simple example of how I would basically exploit privilege and vulnerability. And in that case, I just Googled some code and got a blog post and downloaded the information. So that's basically the DBMS JVM export permissions vulnerability, kind of a very detailed walkthrough of it, and that's how easy these are to exploit. So now we'll talk about a little bit more complex one. So 80 or 90% of the Oracle security exploits are those similar to those two examples. So out of 433 bugs, the vast majority, probably 400, are like those. There are certain cases where there's very complex bugs that are basically what we consider design flaws. There's also an Oracle TNS poisoning attack, which we're going to probably do a webinar coming up on, which is probably the most serious security vulnerability ever released. We'll have a webinar coming up in the next couple weeks discussing that one. But I also want to talk about one that was released in January, which is the Oracle SCN flaw. Again, this one's a little bit more complicated, but I only need create session. It's remotely exploitable without authentication. The answer is no. I need a database session. But if I can create a database link into your database, and all I need is a session to do that, I can basically cause a lot of havoc in your environment. So when we talk about the SCN, is the system change number. So this is an example of something that's been in Oracle for a very long time that someone just all of a sudden one day said, hey, that can cause a big problem if I do something to it. And so the SCN number, think of it as basically internal timestamp. Every transaction has to be ordered. So if I have to roll back a database or do redo, I have to have some ordering of the transactions, and that's what the SCN number does. It's got a huge limit, so basically, theoretically, it's good for 500 years. It's a 281 trillion possibility. It's a 48-bit number, so there's huge amounts of numbers there. What Oracle does, though, is they calculate a current maximum SCN. So every second the database is up, is this maximum SCN number is incrementing. So you get 16,000 per second. So it's very difficult for any database to be all out processing 16,000 transactions per second. And even in that case, a lot of transactions will get the same SCN number within the same second. So that's very possible. The problem is, though, if I hit the current maximum SCN number, I get Aura 600 errors. And theoretically, the database can crash after a certain number. And people have actually proven this out. There's a couple webcasts. So if you go to YouTube and you type in Oracle SCN, you'll actually see a couple YouTube videos that will actually describe this out and actually show people set up proof of concepts of this. I'm going to take a little bit more theoretical approach instead of showing you how it works, because it shows okay, but the theoretical aspects are actually more troubling. So basically, if we kind of illustrate out how the SCN number works is, well, the current SCN increases by basically 1 for every change. That's not always true, but for most changes, it's just kind of going. So if I've got 1,000 changes going on, my SCN will increment by 1,000. But my current SCN will actually increment by 16,000 every second. So it's very difficult for your current SCN to catch up to your maximum SCN. And really, the 281 trillion limit never is reached here because I can't exceed the maximum SCN. I can only exceed the current maximum SCN, and I get into trouble there because then I'll get over 600 errors. And why it's designed this way, I'm not sure. Someone who knows a lot about Oracle internals could probably explain why they would need the current maximum SCN. The problem is if I do exceed the current maximum SCN, the only way to fix it is do a database import and export, unless you wait for a period of time. So if someone is able to actually increment your current maximum SCN by a year above what it should be, and then you have to reset the clock on the database server to basically the current time, your database won't start because the current maximum SCN is exceeded. So the only way to fix this problem is if someone can figure out how to really exploit this vulnerability is to import export your database. So it's very powerful that way that someone could wipe out a lot of databases and cause massive havoc. Well, so the SCN increments for each database change. Well, there is other scenarios where it increments. And the first is distributed transactions. Because if the database is trying to handle a distributed transaction between multiple databases, well, it has to keep the SCN number somehow synchronized. So when two databases connect via database link, they will synchronize to the highest SCN. So now, not only is my SCN incrementing for every change in my own database, the databases together start incrementing their SCNs, and they'll start synchronizing to the highest SCN that via database links. And then truly how this bug was found was that there's actually are some software bugs that Oracle fixed as part of the CPU process. Oracle didn't fix this entire issue. They fixed the software bugs that would cause the SCN to increment out of control. And there's an alter database begin backup bug that if you turned it on to do hot backups and you're not using RMAN or anything, it would cause the SCN to actually increment out of control. And when you turned it off, it didn't turn off this incrementing the SCN. So you'd have one database with a wildly incrementing SCN and connecting to other databases via database links. And we know of 2 large customers that actually had 50 to 500 databases impacted by this, where the databases started crashing, getting over 600 errors, and multiple other issues in their environment. So this is a real-life issue about how it can happen. And hopefully most of the issues have been fixed about these SCN numbers incrementing. So the fundamental flaw that would cause the problem just by naturally happening hopefully has been solved. The problem is if someone now can maliciously come in and exploit the bug, that's where the problem occurs. So Oracle has determined that some software bugs could cause this to happen, and they believe all the software bugs have been fixed that can cause this to happen. What really is happening, though, is the known software bugs are fixed, but any new bug, or if someone can find some method to do this, can actually cause this problem in your databases. And so why does this become a problem? Well, Oracle's hopefully fixed the escalation problem, and they've added some database link sanity checking. So when the database links connect, now they'll be much more readily rejecting the link. So if 2 databases attempt a link and the connecting database is exceeding your database's current maximum SCN, it'll actually reject the connection. And now you can actually tune that a little bit more also. So where are we at today after the January CPU? So if you've applied the January 2012 CPU, what's the ramification? Well, the fundamental flaw still exists. So if someone can figure out how to exploit this flaw and get you to the maximum SCN, you start to get to a problem. And there's actually several methods that allow a single database's SCN to be escalated. So it's very possible to actually crash a single database and get it to the maximum SCN, but you do need DBA privileges, and you have to actually bounce the database to set the parameters correctly. So for a single database, it still exists. It's kind of a problem. Well, but the database links risk still exists. Worst case scenario is if I have time zone differences and my clocks aren't quite set correctly, I can actually stop a database for at least a few minutes, maybe an hour, depending on how things are connected. Because again, the maximum SCN, if I can exceed it, the database will stop processing transactions. Well, we went through and actually did some analysis, and we've actually done for years, looked at database links at different customers of ours as we do our security assessments, because one of the issues is if I can exploit one database, I can actually bring down a lot of other databases. And so this is one example of a large Fortune 500 client of ours that basically we went through and looked at 15 databases, and then we actually analyzed on how those 15 databases were interconnected, and if I exploited and could compromise one database, what was the impact in the organization? Well, now, if you look at it a little bit differently, is if I can increase the SCN on one of these databases, look what will happen to the organization. That maximum SCN will actually propagate to all these other databases. So it's a very powerful potential bug. So here's an example of how the SCN is going. So as you can see, you can very clearly tell of these 6 databases which ones are interconnected. These are basically 6 key production databases of one of our clients when we did an assessment. As you can see, 5 of the 6 databases are interconnected, and their SCNs are basically incrementing very close together. These numbers weren't taken all at the exact same second. If they were, we would assume the numbers would be much closer. These were kind of done over a couple of hours or maybe even a day and gathering the data. But again, your SCN is incrementing very rapidly when you have database links and transactions. So basically for the SCN flaw, the risk to a single database is minimal to none. It's actually possible to crash a single database with a directed attack if the January 2012 CPU is not installed. If you Google Gokhan Atil SCN, you'll actually find a very nice webinar that he gave on this and how he actually did it in his setup. The problem is that if your SCNs are near the current maximum, so the scenario here is if I can go in and do a database connection through a database link, so I just set up a rogue database on my small laptop, and I do a database link because I have an account on one of your databases, I can now pop up the SCN to a much higher number. If I can get it near the current maximum, and in your environment that you aggregate, you've got a lot of database connections going, and your transaction rate across all those databases is close to 16,000, it's possible that I can now start injecting errors into your environment. We're looking for some volunteer organizations that have a large number of Oracle production databases, all interconnected with database links, so we can try this, but we haven't found any takers yet to see if this is if this works in a practical environment. But we know of two scenarios where just by happenstance, large customers, Fortune, actually 100 customers of Oracle, that they ran into this with a limited set of their databases just by due to the backup bug. So it is possible if an attacker wants to jump in and attack this, and this flaw is not fixed. Even if you apply the January 2012 CPUs, you're still vulnerable to this potential attack. So the accidental risk is low. It's very difficult now if you actually aren't using Ultra Database Backup. There's very few possibilities of the SCN rate incrementing out of control. And most database environments don't even have close to 16,000 transactions per second. But we believe a malicious attack is feasible in this scenario. So even if you do have the January 2012 CPU installed, an SCN attack is possible. So we do recommend that customers look at the SCN number, and actually there's a query. Our tool AppSentry actually does this also. We check to see if databases are close to the maximum SCN as a potential risk. So that's kind of a high level to give you a little bit more information and deep dive on a few Oracle security vulnerabilities to give you an understanding of exactly what's in a security vulnerability, why it occurred, and how easy it is to exploit. So we will now open it up to questions. And always, if you ever have any questions, feel free to contact us. We're always more than willing to answer questions. That helps us drive our research and get information back to our clients and people in the Oracle community.
Thank you, Steve. Very informative. We have a couple of questions that's coming from our listeners. The first one is, how do you determine the impact of a CPU patch?
So this is always a question we get, especially with our largest clients. We do with a lot of Fortune 100 companies, that how should they go about and actually do their quarterly patch impact analysis. As part of AppSentry, we are adding in that capability to actually do that across the databases that AppSentry knows about. But in general, kind of the scenario that we've seen work most successfully is you kind of take the CPU announcement each quarter and kind of review it, and probably out of the last 29 out of 30 CPUs, you'd say, well, we need to apply this, and there's a pretty serious security vulnerability. The ones most to look at are anything with create session. Out of 30 CPUs released in the last years, almost everyone would be mandatory to install. And then the only question that then comes is how high of a risk is each CPU? And probably every other CPU is very critical. And then the other CPU as well, you probably need to get it in. We're now recommending most customers move to at least an N-1. So by the time the next CPU comes out, you're working to have gotten the previous CPU applied. We're seeing very few customers that can get them in within 30 days, and most of our clients are getting them in with typically between 30 and 90 days. Where if you're looking at a schedule, we actually recommend you wait 2 weeks before you download the actual patches that you're going to apply. There's a number of reloads by Oracle over time with CPU patches due to bugs. And if CPU patches don't work, it's very typical that you can't install them. We found very few customers that actually have problems once they've installed the CPUs in the last few years. Early on in 2005, 2006 timeframe, yes, there's lots of CPU problems. But in the last 2 years, very seldom have we ever heard of a scenario where once the CPU was applied, did they run into any kind of bugs or issues. Yes, there's still often bugs and issues when you're trying to get the CPUs applied, and that's one of the reasons we recommend waiting 2 weeks. But then go through your typical CPU or go through a cycle of applying them to test and development databases, waiting for a short period, and then putting them into production. We don't really recommend much regression testing anymore. We've got a couple very large customers with 1,000 or 2,000 Oracle databases that basically what they do is put it in several different environments, let it rest for key databases, and then apply it to production without any rigorous testing cycles. So that a lot of these customers are not doing any regression testing of applications because they're applying a CPU patch. PSU patches may require a little bit more because those include a lot of non-security fixes. But that's kind of our recommendation, is how to try to move it through the cycle as quickly as possible, how to evaluate them.
Next question. We are far behind on patches. How do we convince management it is important to apply security patches?
This is a very difficult question. We work with a lot of our clients on how to get management to acknowledge the severity. And typically the problem is not as much management just saying, oh, we need to apply these. It's working to get the downtime, working with the application teams to get them installed, prioritizing them. The first step is always include the CPU patches with almost any other normal upgrade activity. So if you're upgrading an application, if you're doing a database upgrade, CPU should always be there. I think that's kind of the biggest mistake a lot of customers make, is that they're not applying it on a regular basis with everything else. Slipping it in, it's not going to cause many problems by slipping it in with some other activity if you're applying a lot of other database patches or something like that. Then the question is, how do you apply it every single quarter if you don't have another reason to apply it? And just working through your security team. We see a lot more with internal audit nowadays. The IT security auditors are starting to push database security patches more because they realize the mistake. So it's really working with your CIO, your IT security team, your internal audit team to actually prioritize this to the business, because the business doesn't want to apply them. They don't see the real need. And going through and saying, oh, this is critical, this is important, is difficult. And until you can get the support and saying multiple people, including IT security, say we need to apply these, that's you need to cover as a DBA to get it applied.
Well, once you've convinced management that it's important to apply security patches, what process should be used to test the CPU security patches?
So basically testing the CPUs doesn't require much. You should be really applying it to the test and development environments, letting it sit for a little bit, and then working it into production. As you saw, the bug fixes, the single lines of code, very seldom are the fixes more than that. There's really nothing to test. And a lot of times, the actual vulnerability is an abnormal processing event. So every time there's a buffer overflow, the reason there's a buffer overflow is that the programmer didn't think that more than X amount of characters would be passed in, and a database object name is only supposed to be X amount of characters, and the way you trigger the buffer overflow is you pass in 1,000 characters, and then you can execute that code. So there's really nothing to test there, because if it works normally, there should be no problems. SQL injection, all they're doing is changing the SQL statements from concatenating it to use bind variables. A lot of other times in SQL statements, because if you do a SQL statement with an object, like a dynamic table name, they have to concatenate it. So what they're doing then is just basically adding a single check to say, yes, is that a valid table name, and can I do it? So there's not a lot of things to test. Application-wise, in Oracle Business Suite, security patches are very different, but on the database, you should never really see many problems. They shouldn't be changing the way the optimizer works or anything like that. They shouldn't be changing the way backups work. It's just really abnormal processing that someone figured out some way that it was set up wrong, or they could kind of sneak around, and the Oracle's just trying to fix that. And in the first two security bugs, you saw very clearly, it's 2 or 3 lines of code, and they're changing a single permission. They're changing a SQL statement from a bind, or from a dynamic SQL statement to a bind. And that's about it.
Well, how about the PSU patches? How should they be patched?
Okay. Yeah. PSU patches are a little bit different. And our recommendation on CPU versus PSU, if you have a database that you apply database one-off patches to regularly, you should definitely be applying PSUs. If you've got databases that you have no idea what a database one-off patch is and you've never had to apply one, I would always look to apply a CPU. The PSUs have a significant amount of non-security patches. As an example, I think for the 10205 PSU versus CPU for the recent, it was maybe there was 15 security fixes in the CPU, but the PSU patch contained almost 200 patches, individual fixes. 15 of those were security, and the rest were non-security. So when you're applying hundreds of non-security fixes, that can actually change the way things work much more readily. But if you have a large data warehouse environment that you're always applying optimizer fixes and other one-off database patches due to crashes and things, the PSUs can actually be very helpful there. But again, you probably need to do a little bit more testing for the PSUs. So that's kind of one aspect for the CPUs, is to get them in quicker, because theoretically they should change less and break less. Although Oracle support is really pushing the PSU patches as much as possible, because again, they want you to get as many fixes in as possible. And they don't care about your testing requirements and how much effort it takes you to test.
One last question here. One of the listeners wants to know what you get your thoughts on the latest register service poison vulnerability in listener.
Yeah.
Is that dangerous?
Yeah. So basically, April 30th, I think was the exact date, that Oracle basically released an out-of-cycle security fix. And it actually wasn't even a security fix, it was some workarounds. That a security researcher had found a security vulnerability, reported to Oracle, and he had gotten credit in the April CPU. But the credit really wasn't that they had fixed it. The credit was that Oracle said, well, we'll fix this in the future product releases. And so basically he released all the information. So there's basically a zero-day vulnerability for a while that you could basically attack a database very effectively. And then Oracle had to come out with an out-of-cycle fix and say, okay, this is the workaround. So if you go to the Oracle's CPU website, you'll see it not under the CPUs, but under a separate section down below. And so basically what the vulnerability is the Oracle database listener allows dynamic registration. So it's used for RAC, and it's used for very valid purposes. So, when you bring up the listener and you kind of show the services on the listener, unless you've dynamic or specifically stated what instances can connect, there's nothing there. And then when you bring up the database talks to the listener and registers with the listener. Well, you can exploit that functionality by basically being an external system and register a database instance with that listener. And well, if you register it with the same instance name, then it load balances. And since it load balances, it will then send half the connections to basically your database, which then you can then redirect to the original database. So you actually act as what in the security world is called a man-in-the-middle attack. So you can sit there and watch all the database traffic go by and inject your own traffic. And this all requires no authentication. The only thing that's required is I can connect to the database listener port and basically send an attack. And so Oracle recommends there's something called the cost parameters. So it's a secure registration parameter, and basically you can set that to only allow local connections. If you're running a RAC environment, you would then have to start using SSL. Oracle's now providing free SSL licenses, and it's fairly difficult to configure and set up and fix on a RAC database. But in terms of the 433 database security vulnerabilities released ever, actually there's more before the CPUs. The most recent, and it's called the Oracle TNS Poison attack, is probably the most dangerous security vulnerability ever released by Oracle, by far, probably by a factor of 2. We're doing some more research on it. We'll probably have a webinar coming up. There's also additional ways to exploit it. There's detailed exploit code on the internet, very easy to use code that you can basically set up your own proxy and start intercepting connections. And so you can basically take over a database very easily. But again, the key is you have to be able to connect to the database directly. So someone outside your network can't do it, but when someone's on your network, and unless you have firewalls and you're preventing connections to your databases, people can connect and take over your database within minutes. That's not that hard, and there's detailed information about it. You don't need a database session. You don't need anything. So it's very easy to do, and people need to understand that. Our #1 security recommendation is limit access to the databases on the network as much as possible. You should have a firewall in front of the data center, and only certain people should be allowed to access the database directly. and that's typically DBAs. If you need ad hoc database access, you should be setting up a third system to do ad hoc database queries and things like that. So yes, the bottom line answer is yes, you need to very closely look at the Oracle TNS security vulnerability and put the workarounds in sooner than later.